Welcome back to Algebra 2. Today we're going to do some review problems for sections 6 through 8 in Chapter 2, again to prepare you for your test that is coming up. Here in example 1, we want to graph this piecewise function. So what I'm going to do is I'm going to graph each piece, and then I'm going to go back and erase so that I have my restrictions. What I'm going to do first is I'm going to separate my 3 separate lines, and I'm going to graph each of them one at a time. And I'll use the 3 different colors to graph the 3 different lines. So I'm going to put 0, 0 over here. And graphing my first line, y equals negative 2x minus 2. I have my y-intercept at negative 2. My slope is also negative 2. So I'm going to rise negative 2, run 1. Then I'm going to do it the opposite direction, rise 2, run negative 1. And here is my first line. The second line is y equals 1.
Good afternoon, staff.
So as I was saying, I have y equals 1, which I know is a horizontal line that passes through the y at 1. So I have this horizontal line. And my third line is y equals 1/3 x minus 3. So I have a y-intercept at negative 3, a slope of 1/3. Rise 1, run 3, rise 1, run 3. Negative 1, negative 3, and here is my other line. Alright, now what I want to do is I want to erase parts of these lines based on my restrictions. So my first line that we did in black was y equals negative 2x minus 2. The restriction is x has to be less than or equal to a negative 2. So my x value of negative 2 is right here. I'm only going to graph on the first line the x values that are less than or equal to negative 2. So those would be the x values starting at this point and to the left of it. So I want to erase everything to the right of that point. Okay, so there's my first line. Now I want to do my second restriction for y equals 1, so my horizontal line, and it only exists for x values that are greater than negative 2 and less than 3. So here's my x values my x value of negative 2 and my x value of positive 3. So the horizontal line only exists between those two lines. And you can see that it's less than and greater than, so I'm going to have open points. And I need to go ahead and erase again some of the blue. Okay, so there's my horizontal lines. It only exists now between negative 2 and positive 3. My third line, which I did in red, only exists for x's that are greater than or equal to 3. So again, here's my x value of 3. So that red line can only exist greater than or equal to that point, which would be to the right. So I'm going to make this a heavy closed point because it is greater than or equal to, and I need to erase everything to the left of that point. And here's what my final graph would look like. Again, this is a piecewise function with 3 different pieces. Here I want to graph an absolute value function, and we're going to use our shifting and our stretching. So I'm going to go ahead and put my 0, 0 over here. And I'm just going to keep in mind that the parent function crosses through 0, 0, 1, 1, 2, 2, negative 1, negative 1, positive 1, and negative 2, positive 2. So I'm first going to identify that my vertex is at -3, -2, and I'm going to start there. There's my vertex, and then I'm going to shift and shrink stretch the rest of my points. So this has now a shrink stretch of -2, which again your teachers may have talked about. It kind of acts like the slope, but it's not considered the slope. So this is +1, so the new shrink stretch would be at -2, then I'm going to shift it 3 and 2, and actually that was -3 and -2. Do the same thing with this point. This y value was +2. It's going to be -2 times that, so the new y value has to start at -2. I'm sorry, -4. And I'm going to shift it horizontally -3 and vertically -2. I'm now going to reflect the 2 points that I just shifted across the vertical line that goes through the vertex, because I hope you've noticed that the absolute value functions have symmetry, and then I can just draw it in. And there is your absolute value function. Okay, now what I want to do is I want to take a look at that same absolute value function, and I'm going to shift that equation down 3 units and left 4 units. So my vertical shift is going to be down 3, so that would be a -3, and my horizontal shift is going to be left 4 units, which would also be a -4. And since I'm starting with a vertical shift of -2, I'm just going to put -3 minus 2, which gives me a -5. So my total vertical shift would be -5. Likewise, on my horizontal shift started as a -3, so I'm going to put the -3 here, and I get a total shift of -7. So when I write my new equation, I would have y equals, I didn't shrink or stretch any different, so that stays the same. So -2 times the absolute value of x plus 7 minus 5. And there's the new equation after you shift 3 additional units down and 4 additional units to the left. Example number 4 is an inequality that we want to graph, and you just do this as if you were going to graph a line. So I'm going to put 0, 0 right over here. I'm going to graph this line by using the y-intercept, which is -3, and my slope, which is 1/2. So rise 1, run 2, rise 1, run 2, and there's my new line. This is less than, so I'm going to use a dashed line rather than a solid line. And hopefully you guys are using straight edges. I don't know how well this is going to go without a straight edge. Okay, there's my line. Now I want to shade everything that's less than this line, so I'm going to pick the point 0, 0. I'm going to substitute it in and see if I get a true statement or a false statement. So I'm going to get 0 is less than -3. 0 is less than -3 is a false statement. So 0, 0 is not shaded, so my shading would be here. Okay, let's take a look at example 5. On this one, I'm just going to take this little picture, the blue figure, and I'm going to translate it horizontally 2 units and vertically 1 unit. But in addition, I've also got to shrink stretch it by a factor of 1/2. Okay, and again, as you know, I like to do my shrink stretch first. So this y value was 1, so the new y value has to be half of that. So that'd be right here, but now I need to apply my shifts. So I'm going to shift horizontally 2 and vertically 1. So I end up with a new point right there. The next point I'm going to shift is right here, and its y value is 2. Half of 2 is 1, so that'll be right there. Now I need to apply my horizontal shift of 2 and my vertical shift of 1. So I end up on top of the original of a different original point. Alright, now we're going to shift this point, the original point there. Its y value was 2. Half of that is 1. So I'm going to shift horizontally 2, vertically 1. And last but not least, I'm going to use this point. That point's y value is 3. So half of that is 1.5. So I would have up 1.5. Now I have to apply my horizontal shift of 2 and my vertical shift of 1. And here is my new figure. Alright, in example 6, we're going to write an equation of the absolute value function. So I'm going to pick 2 points. I'm going to pick my vertex, which is at 3, -1. And I'm going to pick another point. I'm going to pick this point right here, which I believe is at 4, 3. And I'm going to substitute those 2 points in so that I can find my shrink stretch, my A value. So I've got my vertex is what I'm going to put in first. And then I'm going to substitute the 4 and the 3 of this point into my equation for my x and my y. So this x is going to become my x value, which is 4. And my y value is going to become this 3. So I'm going to have a 3 right here. And then I'm going to solve. Following order of operations, the grouping symbol are the absolute value bars. So I get 3 is equal to A times the absolute value of 1 minus 1. So I'm just going to go ahead and have the 3 is equal to A minus 1. I add 1 to both sides, and A is equal to 4. So my absolute value function is y is equal to 4 times the absolute value of x minus 3 minus 1. Alright, in example 7, we're going to write the equation of this piecewise function. So what I'm going to do is I'm going to write the equation of the 2 lines separately. On this line, I can see that my y-intercept is at -3, and I can calculate the slope as up 1 over 1, up 1 over 1, so my slope is 1. So I just get y is equal to x minus 3. The other line might be a little more difficult. I want to start on this one by finding my slope. So I'm going to look at this point and this point, and I'm just going to count my slope. So I have a rise of -1 and a run of +2, so my slope for this one is -1/2. So I know that I've got y equals -1/2 x. Now I need to figure out what my y-intercept would be just by following the slope. So rise 1, run 2, rise 1, run 2, and my y-intercept would be a +2. So there's my 2 equations of lines. So I'm going to go ahead and write over here that I'd have f of x is equal to x minus 3, and we'll fill in the if statement in just a minute, and -1/2 x plus 2, and again we'll fill in that if statement in just a minute. So to figure out the if statement, we need to look at this value right here, and if you count, that value is at a +4. And my blue line is only graphed for x values that are less than 4, so I'm going to write x less than 4. And again, I know it's not equal to 4 because I have an open point here on the blue line. The red line is graphed for everything to the right of the 4, so that would be x values that are greater than or equal to 4. And again, I know it's equal to because that was a solid point. So here is your piecewise function for this graph. Now what I want to do is I want to create a scatter plot. I'm going to go ahead and put my 0, 0 right here. And I'm just going to count my ones on this. Plot a point at 0, 4.5. And I'm going to go ahead and make this graph and then we'll look at it. All I'm going to do is plot the points, and I'm counting by ones. Okay, so there's my scatter plot again. All I did was plot the points that are in the table. Now I want to determine the trend line. So I'm going to go ahead and draw in what might be the trend line, and then we'll calculate it. Again, the trend line is your line of best fit. It touches as many of these points as possible and balances the remaining points. So there's my trend line. Now what I'm going to do is I'm going to pick 2 points on that line, and I'm going to go ahead and calculate the slope and the rest of the equation. And I'm going to pause and do that work, and then we'll start it up again. Maybe you should try it as well. I guess you already have. Hopefully you got the same thing I will. Okay, I calculated my slope. I got a -1 for the slope, and now I'm going to take the point 5/10, 4, and I'm going to substitute that back into the equation to find my b value. Okay, so here's my equation of my line. Y equals -x plus 4.5. Alright, so I didn't fool some of you. You realized that the y-intercept was right here in the table. And that's fine if I didn't fool you, but for the rest of you, you might want to pay attention to that. And if I did fool you, it was a good review, because we all need to remember how to find slope, and we all have to know how to write the equation of a line. Let's go on to our next example. Here we have an inequality that's been graphed, and we want to actually write the equation of this line. So again, I'm just going to write the equation of the line, and then we'll deal with the shading. First thing I notice is that my y-intercept is at 1, so I know I have a +1 at the end, and then I can find my slope. I'm just going to count it. It's a rise of 2 and a run of 1, so my slope is +2. So I have y is equal to 2x plus 1. If I just had a line, that would be my equation and I would be finished. But I actually have shading, so I know this is an inequality. So if you can kind of look at this picture and decide, is the shading above the line or is it more below the line? And if it's to the left of the line, it's actually above it. So I know that this is going to be y is greater than 2x plus 1. In addition to that, though, I need to decide if it should be greater than or equal to. And because my line over here is solid, it does have to be equal to. So here's the equation of this, the inequality of this graph. Alright, so in example 10, you and your classmates are measuring their heights and the head circumference. The results are in the table. And you're wondering if the circumference of your head is about 23 inches. Based on this data, how tall would you be? So 23 is in here between 22 and 24 inches. So your height should be over here between 64 inches and 72 inches. So you can just say that your answer is going to be between 64 to 72 inches. And it's not an exact science. We don't know the answer exactly, but it's going to be between those two. In example 11, we actually want to graph this inequality. You'll notice this one is written in standard form, so I'm going to do this one different. I'm going to find my x-intercept, which if I put a 0 in for the y, my x-intercept will be at 2. And my y-intercept, if I put a 0 in for the 2x, will be at -4. So I'm going to graph that line. Again, my x-intercept is at 2, and my y-intercept is at -4. and it's less than, there's not an equal to, so it's going to be a dashed line. And again, to figure out where I'm going to shade, I'm just going to substitute in zeros and see if I get a true or a false statement. So I get 0 is less than 4. And that is certainly a true statement, so I'm going to shade over the 0, 0, which is to the left. Okay, so I'm recording here and didn't realize that. Sorry. Let's go back to that last example we were on. In example 12, I want to evaluate the function for the values x equals 3, x equals 0, and x equals -3. So in order to do that, I need to find on the function when does x equal 3. Well, if I substitute 3 in here, I've got 3 is less than or equal to -2. That's false. If I substitute it in here, that again is false. But if I substitute the 3 in here, I get a true statement. So I'm going to use this function. So I have 1/3 of 3 minus 3, 1 minus 3, so I get -2. So when x equals 3, my function will equal -2. I also want to evaluate when x equals 0. So again, I need to figure out which one of these is true. Is 0 less than or equal to -2? No. Is 0 between -2 and 3? Yes, it is. Is 0 greater than or equal to 3? No. So I'm going to use my second function. And since this is a horizontal line, I don't even have to do any math. I know that when x is 0, my function will be 1. And I want to do the same exact thing when I have x equals -3. Is -3 greater than or equal to 3? No. Is -3 between -2 and 3? No. Is -3 less than or equal to -2? Yes, it is. So I want to use my first function here, so I'm going to substitute the -3 in there. And so when x is equal to -3, my function is 4. And last but not least, we're going to look at an example here of an internet cafe. You have the following data that shows you the charges that this internet cafe uses so that it can calculate how much money you're going to owe them each time you get on the internet. Now, this function is going to be a step function, and what I'm going to do to make this go a little bit quicker is I'm going to actually pause the video and make the graph, and then I'm going to explain it to you. Alright, so here's my graph. You can see that my independent variable is the time, and I meant for that to say hours, but it says HSS, so we'll rewrite that. My time is in hours along the bottom, and I chose hours because I didn't want to use the large numbers, 60 minutes all the way up to more than 300 minutes. My y value, my dependent variable, are the charges or the money that it's going to cost you to use the internet. You can see in the table that 60 minutes or less is going to be $3. So 60 minutes is from the second you walk into the cafe and start using that internet all the way up until that first hour. If you don't use the internet, you don't get charged, so I have an open circle. And then if you only use it for 60 minutes, you do get charged the $3, so right there I have a closed point. And then I connect the 2 points with a line. From 61 minutes to 180 minutes, you're going to be charged $6. So 61 minutes is just after an hour, so I put an open circle at the hour mark. and a closed point at the 180 minutes, which is 3 hours, and then I connect the two with a line. 180 minutes to 300 minutes is $8, and that's just over 3 hours, so I put an open point at 3 hours, indicating that 3 hours doesn't cost you $8, but it is a boundary point. And then I put a closed point at the 5 hours, because 300 minutes is 5 hours, and then again connecting the two with a line. Last but not least, anything that's more than 300 minutes is going to cost $9. So again, I put an open point to indicate that at 5 hours you are not charged $9, but then drew a line with an arrow indicating anything more than 5 hours would be $9. Thanks. Hope you did well on the review, and look forward to seeing you in class. And remember to study for your test.